How a jet engine works. This simplified diagram shows you that process through which a jet engine converts the energy in fuel into kinetic energy that makes a plane soar through the air. For a jet doing slower than the speed of sound, the engine is moving through the air at about 1000 km per hour, 600 meter per hour. We can think of the engine as being stationary and the cold air is moving toward it at this speed. A fan at the front sucks the cold air into the engine and forces it through the inlet. This slows the air down by about 60% and its speed is now about 400 km per hour to 40 meter per hour. A second fan called a compressor squeezes the air, increases its pressure by about 8 times, and this dramatically increases this temperature. Kerosene liquid fuel is squirted into the engine from a fuel tank in the plane's wing. In the combustion chamber just behind the compressor, the kerosene mixes with the compressed air and burns firelessly, giving off hot exhaust gases and producing a hug increase in temperature. The burning mixture reaches a temperature of around 900 degrees Celsius, 1650 degree Fahrenheit. The exhaust gases rush past a set of turbine blades, spinning them like a windmill. Since the turbine gains energy, the gases must lose the same amount of energy, and they do so by cooling down slightly and losing pressure. The turbine blades are connected to a long axle represented by the middle gray line that runs the length of the engine. The compressor and the fan are also connected to this axle. So, as the turbine blades spin, they also turn the compressor and the fan. The hot exhaust gases exit the engine through a tapering exhaust nozzle, just as water squeezed through a narrow pipe accelerates dramatically into a fast jet. Think of what happens in a water pistol. The tapering design of the exhaust nozzle helps to accelerate the gases to a speed of over 2100 km per hour, 1300 meter per hour. So the hot air leaving the engine at the back is traveling over twice the speed of the cold air entering it at the front, and that's what power the plane. Military jets often have an underburner that squirts fuel into the exhaust jet to produce extra thrust. The backward moving exhaust gases power the jet forward because the plane is much bigger and heavier than the exhaust gases it produces. The exhaust gases have to zoom backward much faster than the plane own speed. In brief, you can see that each main part of the engine does a different thing to the air fuel mixture passing through. Compressor dramatically increases the pressure of the air and to a lesser extent its temperature. Combustion chamber dramatically increases the temperature of air fuel mixture by releasing heat energy from the fuel. Exhaust nozzle dramatically increases the velocity of the exhaust gases, so powering the plane.